So today we are going to start lines and angles, that is chapter 4. Okay, fine. So one by one concept I am showing to you, just check it. So very important quote this here. Your best quote that reflect your approach is one small step for man, one giant leap for the mankind. Okay, fine. Now we learn here angles. So an angle, acute angle, some types of angle we have to keep in our mind. Okay, an angle, an angle, an acute angle measures between 0 to 90 degree, whereas a right angle is exactly equal to 90. An angle greater than 90 but less than 180 is called the obtuse angle. Also recall that a straight angle is equal to 180 degree. An angle which is greater than 180 degree but less than 360 degree is called the reflex angle. Further, two angles whose sum is 90 degree are called complementary angles. If sum of two angles are sum of two angles is 90 degree, that is called complementary angle. Can you give one example, Aksara?
Angle 45, angle 40 plus angle 50.
Yeah, 40 plus 50, right? 40 and 50 are complementary angle. And two angles whose sum is 180 degree are called supplementary angle. That means if sum of two angles equals to 180 degree, then that number are called supplementary angle. Can you say its example, Akshaya?
Sir, angle 100 plus angle 80.
Right, very good. So angle 100 plus angle 80 will be the supplementary angle. Okay. Now here we have to learn adjacent angles. So what is adjacent angle? Two angles are adjacent. Two angles are adjacent if they have a common vertex. See here ABD and CBD. These two angles we can observe one common vertex. B is here common and and uh, and a common arm. Here BD is the common arm and their non-common arm are on different side of the common arm. That means common arm is BD. Okay, BC present in one side and AB present in other side. So these two angles, that is ABD and CBD, these two angles are called what? Adjacent angles. So angle ABD and DBC are adjacent angles. Ray BD is their common arms and point B is their common vertex. Ray BA and ray BC are non-common arms. Moreover, okay, moreover, when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. So we can write angle ABC equals to angle ABD plus DBC. So angle ABC, you can say that. So here angle ABC equals to ABD plus DBC. Okay. So understood, Aksara?
Sir?
Understood?
Yes, sir.
ABC can be written as angle ABD plus angle DBC. Okay? Okay.
Yes, sir.
Now next concept come here. Linear pair of angles. Right? If two non-common arms BA and BC in figure 6.2, in previous figure, if you'll observe, okay, BA and BC forms a line. If it will form a line, then it will looks like figure 6.3. Here this. Yeah, if BA and BC, okay, just will form a straight line. In this case, angle ABD and angle DBC are called linear pair of angles. Linear pair. Okay, adjacent, these two are adjacent angles. But here special condition came. Your BA and BC are just oppository. So it will form a straight line. So then that adjacent angle, okay, we can say linear pair of angles. Understood? Okay. Okay, now vertically opposite angle. Many times students are not understanding the meaning of vertically opposite angles and how vertically angles will be formed. Angles formed when two lines, say AB and CD, intersect each other. Say at the point O, there are two pair of vertically opposite angle. One pair each angle AOD and BOC. AOD and BOC. And other pair tell, who will tell?
Sir, AOC and BOD.
AOC and BOD. Okay, correct. Very good. Other pair is this. So next is linear pair axiom. Okay, so what is the meaning of axiom? Okay, axiom and postulate. These two terms you will get in chapter 5. Axiom means, okay, after experiment. Okay, many experiment, if any mathematician conclude that this is true for all, and if whole world will accept that statement, that is called axiom. Okay, so this is called linear pair axiom. So in case of linear pair, okay, sum of two adjacent angle will be always 180 degree. If a ray stand on a line, then the sum of two adjacent angles so formed is 180 degree. And recall that when the sum of two adjacent angles is 180 degree, then they are called the linear pair of angles. That means both are the linear pair axiom. Now, here some angles, adjacent angle we can observe. Okay, case 1, case 2, case 3 and case 4. Okay, so here only one case 3 if you observe, then these two adjacent angle is forming linear pair. So different kind of adjacent angle we can observe here, right? Now, linear pair axiom, here just axiom 6.2, one more axiom we are getting. If the sum of two adjacent angle is 180 degree, then the non-common arms of the angles formed a line, right? That means here axiom 6.1 and 6.2 both together is called linear pair axiom. So for obvious reason, the two axiom have together is called the linear pair axiom. Okay, now here proof. If two angles intersect each other, then the vertically opposite angles are equal. So this proof, okay, is important, and in examination also we are getting. So now just one video I'm showing. Just watch this video. Okay.
Introduction.
Hey Ajay, look at the stars.
Wow, they're looking so beautiful. They look like points.
Yes. Do you know what do we get if we join 2 points?
Yes, we get a line.
See that Big Dipper? Here, all the 7 stars are joined.
And Didi, what happens when two lines intersect each other?
Good question. When 2 lines intersect each other, then angles are formed. Come, I will tell you more about lines and angles and their properties.
Objectives. At the end of this lesson, you'll be able to define line, line segment, ray, and angle. Differentiate between intersecting lines and non-intersecting lines. Relate between the angles formed when a ray stands on a line. Write the axioms based on pairs of angles. Prove the given theorems. Find relation between parallel lines and transversal. Prove theorems and examples related to lines parallel to the same line. Prove the angle sum property of a triangle. Basic terms and definitions. We know that a part or portion of a line with two endpoints is called a line segment. The line segment AB is denoted by this symbol. A part of a line with one endpoint is called a ray. The ray AB is denoted by this symbol. And the line is denoted by this symbol. We also know that if three or more points lie on the same line, they are called collinear points. Here, A, G, F are called collinear points. And points B, C, and E are called non-collinear points. Now come to an angle. An angle is formed when two rays originate from the same endpoint. The rays making an angle are called the arms of the angle, and the endpoint is called the vertex of the angle. We know about different types of angles like acute angle, right angle, obtuse angle, straight angle, and reflex angle. Let's go through them one by one. Types of angles. An acute angle measures between 0 degree and 90 degree. A right angle is exactly equal to 90 degree. And an angle greater than 90 degree but less than 180 degree is called an obtuse angle. Also, a straight angle is equal to 180 degrees. And an angle which is greater than 180 degrees but less than 360 degree is called a reflex angle. We also know that two angles whose sum is 90 degree are called complementary angles. What do we call the angles whose sum is 180 degree? Yes, you are right. They are called supplementary angles. Types of angles. Another question, what do we call those angles which have a common vertex, a common arm, and their non-common arms are on different sides of the common arm? They are called adjacent angles. Here ABD and DBC are adjacent angles. Ray BD is their common arm and point B is their common vertex. Ray BA and Ray BC are non-common arms. Also, when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. So we can write angle ABC is equal to angle ABD plus angle DBC. If the non-common arms B and BC form a line, then it will look like this. Then the angles ABD and DBC are called linear pair of angles. When two lines, say AB and CD, intersect each other, say at a point O, then the angles formed are called vertically opposite angles. These are two pairs of vertically opposite angles. One pair is angle AOD and angle BOC, and the other pair is angle AOC and BOD. Intersecting lines and non-intersecting lines. Now let us draw two different lines PQ and RS on a paper. We can draw it in this way also. We have seen that we can draw them in two different ways. These are intersecting lines and these are parallel lines. And the length of the common perpendiculars at different points on these parallel lines is the same. This equal length is called the distance between two parallel lines. pairs of angles. Now let us find out the relation between the angles formed when a ray stands on a line. Look at this figure. Here AB is the line and OC is the ray. Angle AOC, angle BOC, and angle AOB are the angles formed at O. Can we write angle AOC plus angle BOC is equal to angle AOB? Yes, because angle AOC and angle BOC are adjacent and angle AOB is the angle formed by the two non-common arms, and we have studied that when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. Mark it as 1. The measure of angle AOB is 180 degree because it is a straight line. Mark it as 2. From 1 and 2 we can say that angle AOC plus angle BOC is equal to 180 degree because angle AOB is 180 degree. This gives an axiom. Let's go through it. Axiom 1. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. We know that if the sum of two adjacent angles is 180 degree, then they are called a linear pair of angles. Given that a ray stands on a line, from this we can conclude that the sum of two adjacent angles so formed is 180 degree. Let us write this axiom the other way. That is, we will take the conclusion of the axiom as given and the given as the conclusion. So it becomes, if the sum of two adjacent angles is 180 degree, then a ray stands on a line, that is, the non-common arms form a line. Now we can see here that the axiom and this statement are reverse of each other's. Let us now check whether this statement is true or not. Draw adjacent angles of different measures. Keep the ruler along one of the non-common arms in each case. You will find that only in this figure, both the non-common arms lie along the ruler, that is, points A, O, and B lie on the same line and ray OC stands on it. Also, we can see that angle AOC plus angle COB is equal to 125 degree plus 55 degree, which is equal to 180 degree. From this we may conclude that this statement is true. And we can state it in the form of another axiom, which is, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Axiom 2. We get two axioms now. These two axioms together is called the linear pair axiom. Let us now move to the case when two lines intersect each other. We know that when two lines intersect, the vertically opposite angles are equal. We will prove this result after a small interactivity. Theorem 1. If two lines intersect each other, then the vertically opposite angles are equal. Let's prove this theorem. In this statement, it is given that two lines intersect each other. So, let AB and CD be two lines intersecting at O. They lead to two pairs of vertically opposite angles, namely degree AOC and degree BOT, degree AOT and degree BOC. We need to prove that degree AOC is equal to degree BOT and degree AOT is equal to degree BOC. Now, ray OA stands on a line CD. Therefore, degree AOC plus degree AOT is 180 degree. Linear pair axiom, mark it as 1. Similarly, angle AOT plus angle BOT is equal to 180 degree. Mark it as 2. From 1 and 2 we can write angle AOC plus angle AOD is equal to angle AOD plus angle BOD. This implies that angle AOC is equal to angle BOD. Similarly, it can be proved that angle AOD is equal to angle BOC.
PPT. So concept we have understood. Okay. Okay, Akshay.
Yes, sir.
Now question number 1, 2, 3, 4. These 4 questions. Once again, just try to understand very quickly. I'm explaining this. Answer 1. So if we draw the figure,
Sir, we should write in the book.
yeah, already you have written, I think.
Yes, sir. We have to.
So this video already you will get. So this is a ray and one more ray going like that. Just understand once again. So from here one ray is going this direction. So this is A and this is B and this is C, this is D, this is O and this is E. Right. So first we have to write what is given. So here main point of given things is angle AOC plus angle BOE equals to 70 degree and angle BOD equals to 40 degree, right? Okay, now to find what we have to find. So to find one, we have to find BOE and reflex angle COE. Now its solution. Angle AOC equals to angle BOD. Reason? Vertically opposite angle. So angle AOC we are getting, BOD already we know 40 degree. Right. Again, angle AOC plus angle BOE equals to how much? 70 degree. Now AOC we are getting 40 degree plus angle BOE equals to 70 degree. So angle BOE we are getting 70 degree minus 40 degree. So angle BOE equals to how much? 30 degree. So one answer we got. After that we have to find reflex COE. So first COE will find angle AOC plus angle BOE plus angle COE. How much? 180 degree. Now AOC plus BOE already we know 70 degree plus angle COE equals to 180 degree, right? So here we are getting angle COE equals to 180 degree minus 70 degree. So angle COE equals to 110 degree. So reflex COE we have to find reflex angle COE will be 360 degree minus angle COE. right? So 360 minus angle COE equals to 360 degree minus 110 degree. So it will be how much? 360 minus 110, how much? 250 degree. So this was our first question. Now I am doing third question. Now answer 3. Alternate questions I will do, and remaining questions you will complete. So here one triangle P, Q and PQR produce this side and produce this line also this side. So this is S and this is T. So this angle and this angle relation is given. So here given is angle PQR equals to angle PRQ. Now to prove, angle PQS equals to angle PRT. Now proof. Now angle PQR plus angle PQS equals to 180 degree. Region linear pair axiom. Again angle PRQ plus angle PRT also 180 degree. This is also linear pair axiom. So from these two equations, equation number 1, equation number 2. So from equation 1 and equation 2 implies angle PQR plus angle PQS equals to angle PRQ plus angle PRT. Now PQR and PRQ, these two are equal, so we can cut from both sides. So angle PQS equals to angle PRT. So this was question number 3. Now see answer 5. Okay. So up to question number 4 already you did. Question number 5 I am showing in this figure. So draw this figure quickly. So draw a figure. Now here one perpendicular line, perpendicular ray. Draw it. Then here draw another ray. So this is P and this is Q, this is O and this is R and this is S, right? And this is 90 degree. So now write given. So here what is given? In figure, POQ is a line, ray OR perpendicular to PQ. So OR main given part, OR is perpendicular to PQ. OR and OS is another ray lying between the ray OP and OR. We have to prove, and given is figured also. Figure also given. Now to prove. So we have to prove angle ROS equals to half of angle QOS minus angle POS. Right? Now proof. Now see here, angle QOS can be written as this angle is 90 plus angle ROS. This is equation number 1. And angle POS can be written as 90 degree minus angle ROS. This is equation number 2. Now difference between these two will be 1 minus 2. If you subtract these two equations, so we are getting angle QOS minus angle POS. Then 90 will be cancelled. We'll get 2 angle ROS. So we can say ROS equals to half of angle QOS minus angle POS. Hence proved. So understood? Understood, Akshay?